Welcome. In this video, we are going to see about JDK, JRE, JVM and bytecode. So let's learn one by one. Before that, we will learn some basics. So what is the basic concept of computing? So we already seen Java is a programming language as well as a platform. So what does mean by platform is, if you need to run a program, the program has to run on something. So here that is a platform. For example, if you wanted to play a cricket game, so you have to go to the cricket ground and you have to play the game. So you can't go into the football ground and you can't play the cricket efficiently. You can play cricket in the football ground but not efficiently. So if a program wants to run in a platform, the platform must support the game or support the software. So here Java acts as both as a platform as well as application. So here assembly language is a language that is understandable by the computer. So we will see that. So consider this an example. In this, I think if you are familiar with this machine coding, so you might understand what this is. So here you have to store some values and then you have to add the values, then you have to store the result to a location. So first the program store 1 comma location A, store 2 comma location B, then we have to add location A and location B, not location, the values in that location, then we have to store the result. This is a program. Next, this program will be given to assembler. So that assembler will give the numbers, that is the number is nothing but zeros and ones. This is understandable by the machine. So the machine understands this program and run accordingly. So here all the processors will have different assemblers. Consider this. So before assembling, there is one more step is called as compilation. In compilation, the program is converted into a machine code. It is not actually machine code, it is intermediate code. So that intermediate code is converted into machine code using assembler. So here the problem with traditional system is you have to have different compilers and different assemblers for each programs. Not each programs, each platforms or each softwares. So in this case, we are running on using 3 machines, Intel machine, AMD machines as well as IBM machines. So we should have different compilers and different assemblers. Each compiler will generate different kind of intermediate codes. Then that will be converted into assembly language code. Then the processor understands that. So this is what happens in case of C is also working on the basis of this, because if you compile a C program in Windows, it will generate executable file, that is exe file. So if you run the program on Linux, it will generate, I think, some kind of binary files. So this is one issue. So to overcome this, Java introduced Java Virtual Machine. So here, once the Java code is compiled, it will be converted into bytecode. So that bytecode is unique. All the applications, all the different processor architectures uses same bytecode, but according to the different architectures, the Java virtual machine will generate the different assembly codes. So the program will run without any problems. So instead of having different kind of assemblers for different kind of processors, Java virtual machine uses simple mechanism to solve this problem. So what are the steps that is available in this applications? First, you have to compile the code. So normal Java program will be compiled into bytecode, okay, or class files. So normally Java will have the extension .java, Java files extension is .java. Once it is compiled, it is converted into bytecode. The bytecode's extension is .class, .class. So this bytecode is unique. So there may be one question, how Java is platform independent. So the simple answer is through bytecode, Java is platform independent. Then this bytecode will be understood by Java virtual machine. Then the Java virtual machine will execute the bytecode. So where is JVM resides? Java virtual machine resides in your system RAM. That is, in your computer there is a part called RAM. In the RAM, Java virtual machine resides. What is JVM? First we will see. Java virtual machine provides runtime environment to execute Java bytecode. In other words, if you want to execute a Java code, you need JVM. So it is have a lot of works. Some of the important works of exception handling, garbage collection, and storing some values. All these things are done by Java virtual machine. Next one is, what are the tasks in Java virtual machines? So simply speaking, 4 tasks JVM does. First one is loads code, verifies codes, execute code, and provide runtime environment. So this is the architecture. So in this architecture you can see class loader, method area, heap, stack, PC register, native method stack, execution engine, native method interface, native library. So let's see one by one. First one is class loaders. So class loaders loads all the class files required for execution. So if you wanted to run a program, all the files will be in the format of .class extension. So the class loaders is loading all the files. Next one is method area. So it is like a constant pool. So here all the methods are stored inside the pool. Heap and stack both are all memory locations. So heap is in which objects are allocated. So objects are stored in heap, and in stack local variables are stored, as well as some part of partial executions are also stored in stack. So program registers, so what is the execution or what is the instruction that is executed are stored here. Next one is native method stack. So it contains all native methods that is used in our application. Executive engine. So execution engine controls the execution of instructions contained in the method of the classes. So it is responsible for executing. Native method interface. So interface we will study a little bit later. So this is used to provide Java code and native code during execution. So library is nothing but to support native method interface, we need some libraries that is provided by native method libraries. Now we will see what is JRE. JRE, if you want to support JVM needs lot of small libraries or small environments. But the problem is, since JVM is inside the RAM, you can't store the complete data set into the or instruction set into the RAM. So JRE provides what is the required libraries and required environment at the moment for the JVM. So JRE is Java runtime environment. It is used to provide the runtime environment. It is having libraries and other components. So it doesn't have any tools. So we will see where exactly JRE is in a little bit later. Next one is JDK. It is called as development kit. Whatever the tools we are using for development, whatever the tools we are using for compilations, whatever the tools we are using for debugging, all these things inside the JDK folder. Okay,